Hi, hello everyone. I'm Jaysri here. Already we are discussing about what is decision tree and important terminology of the decision tree and how decision tree will be work and how attribute selection method that when ASM will be select how will be select the features using information gate. These all the things are learned in previous video. Now we are discussing about GINI. How will be feature selection? How attribute selection method achieve through the GINI method? Okay, what is the GINI? GINI is a measure of inequality in sample. That means value between zeros and one. Value between zeros and one. Zeros means all the elements are similar. I already say if you have one back you are by in back you have all the balls are green color, your entropy will be zero. Similar to the all the balls are green, your guinea is will be zero. That means all the elements are zero, all the elements are similar. Okay. Mostly the guinea work with the categorical target variable. That means failure and success. That means failure and success. Okay. So it perform mostly binary split. Binary split means zero means failure, one means success. So Guinea is a mostly works with a categorical target variable such as failure, success. It's performed the binary splits. Okay, and CORT method, that means classifications and the regression technique. CORT method, classification and the regression technique. What is the CORT method means? What is the CORT? And there are various algorithms that are used to generate the decision tree such as CORT, ID3, cart ID3, CHAID, ID5. These are all the things using these methods, decision tree will be generated. Here, Guinea use cart method. Cart method means it's a classifications and a regression tree. Okay. Mm, how will be calculate the Guinea for split? First of all, calculate Guinea for subnodes using sum of square. That means how will be calculate? First, calculate Guinea subnodes. Calculate Guinea for subnodes. Okay, we're using sum of square. Sum of square means p square plus q square. The p square plus q square means p is a success, q is a failure. So sum of square of probability of failure and the success. Then second step, calculate the Gini for split using weighted score method. Using weighted score method. These two steps are followed by the calculate the Gini for split. Okay. Now let's look at some example, and I will clear my drawings. Okay, already say one example in previous information kind. Let's assume I, I have 30 students record. In 13, I split gender wise. 10 students are male and 20 students are my female. Okay, then year, second year PG and third year UG. Okay, this is my input. Let's assume just this input. Okay, no split diagram. Okay, 30 students split. How split? Gender wise. Is a male or female? Okay, 10 students are male, 20 students are female. In male, out of 5 students are placed during the lockdown time, and female 12 students are placed in during lockdown time. Okay, this is gender wise split. Okay, this is a gender wise split. This is a 60 percentage and 50 percentage. These all the things are discussed in previous video. Okay, now split year wise. Second year UPG and third year UG. In second year UPG, totally 14 students. Third year PG is totally 16 students. Out of 14 students, 8 students are placed during lockdown time and out of 60 students, 9 students are placed in the lockdown time. Okay, this is the our data, this is our example. Okay, now how will we apply the Gini index? Okay, how will we apply our Gini formula? Is already we know what is the Gini formula. It is the p squared plus q squared. P square plus q square means is a sum of square of probability of the failure and this success. Okay, sum of square probability of failure and success. Okay, P is denoted as a success, Q is denoted as a failure. Okay, now in our let's look at the first of all I apply the Gini index for a female data set. Okay, okay. In female 60 percentage of the success, so that means 0.6. Okay, so our formula is p squared plus q squared. So first of all 0.6 squared, that means 0.6 into 0.6. Now plus failure point is 0 point remaining 4, 0.4 into 0.4. So approximately our rate is 0.82 something. Okay, in male similar to using this method. Okay, approximately our rate is 0.55. Okay, both male and female in gender wise calculate the Gini for split. Totally 10 students for male out of 30. Our Gini rate is 0.55 plus out of 20 students out of 30 in female. Our Gini index in female is 0.82. After solving this number, we get approximately 0.70 something. Approximately, not exactly, it is the approximate answer. Okay. The Gini rate of gender is 0.70. In Gini impurity is means Gini impurity. Gini impurity means 1 minus 0.70 something. So we'll get out of approximate some answer 0.6 something. Okay, 0.69 something. Okay, out of some out of 0.69. Okay, this is a gender wise Gini value is 0.70 and Gini impurity. Now we can calculate similar to the year wise. Year wise, first of all, you can find out the second year 0.51, then 0. Third year 0.48. After that, I can apply Gini index split for the year, both the second year and third year. We can got of the in Gini index for 0.55 something. After we get Gini index, we can compute the Gini impurity using 1 minus computed value 0.55. Now we got some value 0.5 something. Okay. Now let's look. Here is a 0.5 etc something, and gender is a 0.6 something. Now look at which feature is more high value is a gender column is high value. Okay, gender column is a high value. So you can node split will the place in gender. Node will be split in place in gender. Gender is a high split. Okay, gender is a high split. This is the Gini index. We are already discussing information gain attribute selection function. Here gender is using Gini index. These two methods are very important. Mostly recommended series information gain. Okay. uh, Now what is the advantage and disadvantage of decision tree? Mostly in decision tree we have less effort for the data preparations and data pre-processing, because decision tree doesn't consider any null value. Okay, at the same time in your decision tree, suppose if you want change in small changes in your data, you can this small changes in data, it can reason of it can reflect of large changes in the structure of your decision tree. And decision tree is a calculate the more complex. compared to the other problems. This is the drawback of our decision tree. Okay, in next video we can how will we overcome these disadvantages through random forest, adapt boosting, XG boosting. Okay, these are all the things are okay. Thank you so much.